In today's episode, Marcos Hernandez tells us about container networking.
Kubernetes networking is networking. Kubernetes networking is as real as physical networking.
The amazing capabilities of eBPF.
The way eBPF works allow you to basically isolate these programs and run them in a specific safe execution environment.
And the future of networking.
If I go to Cloud A, I have to do APIs of Cloud A. If I go to Cloud B, I have to do APIs of Cloud B. Is there a universal API? Well, Kubernetes seems to be it, right?
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Welcome back to Cisco Tech Stories. This is part 2 of our special mini-series on Isovalent, Cilium, Tetragon, eBPF, and containers.
In our first episode, we explored the technical foundation behind these technologies, and in this one, we will be shifting gears and looking at the bigger picture.
We're joined by Marcos Hernandez for a conversation focused on strategy, positioning, and business value of the technologies we laid out in the previous episode. Don't worry if you didn't listen to the previous one, they can be listened to independently. In this one, we'll discover how Kubernetes container network is starting to look a lot like regular fabric networking.
So if episode 1 was about how the technology works, this episode is about why it matters to organization and how to tell that story. Let's welcome Marcos Hernandez, Distinguished Technical Marketing Engineer at Isovalent. Hello, Marcos.
Nicholas, Tristan, nice to be here. Thank you for hosting me.
Can you introduce us a bit your career path and what you're doing right now?
I'm a Cisco boomerang, which means that I'm rejoining Cisco after being away for a number of years. And before that, I held some roles at Google and before that at VMware. So yeah, that's kind of my background.
But a lot of virtualization, right?
Yes. So that's in terms of, the companies that I work for. But my focus has been networking in all these positions, right? It's data center networking, cloud networking for the last 13 years. I've been mostly focused on private and public cloud networking, and more specifically, network virtualization and providing network solutions for virtual infrastructure, but also doing a lot of Kubernetes.
Nice. And now you're working in Cisco, but for Isovalent. So do you mind introducing what that division is, what you guys do, and what you're working on?
Absolutely. Isovalent is a company that was founded, this year we'll celebrate our 10-year anniversary. So the company has been in the market for almost a decade. And before I tell you what we're doing inside of Cisco with this acquisition, let's talk about why Isovalent is so important. Isovalent, we are the creators of what is undeniably the most sophisticated cloud networking technology that exists currently, and that is based on a revolutionary concept called eBPF. eBPF at a very, very high level is a capability that Isovalent developed, invented, and then open source that allows you to basically run arbitrary programs in the kernel of your compute node without revising or revamping or upgrading or patching that kernel. So essentially, at a very, very high level and in very simplistic terms, eBPF makes the kernel of your compute infrastructure a programmable layer that allows you to, run arbitrary programs. Immediately after the Isovalent team invented this, they found applications for this technology around networking and security. What we're doing essentially is pushing to the kernel network and security services that have been handled traditionally by network appliances, or in the case of distributed compute, have been handled by user space in those kind of deployments. So we are essentially distributing all these network services to the various compute nodes and doing that in the most efficient manner by delegating the processing of that traffic and the processing of those services to the kernel of those compute nodes.
I have a newbie question already, if I may. So my basic Linux knowledge is that kernel is good because you have a lot of power, but it's very dangerous. So normally, historically, you don't want to run too much stuff on the kernel because you might break stuff. And that's why everything runs in the user space. But then some apps kind of need kernel access, right? So is this a technology that allows to safely run in the kernel? And then does that mean you want to move literally everything to the kernel thanks to that? What's the point of doing that?
The way VPF works and the security guarantees that we provide in the kernel allow you to basically isolate these programs and run them in a specific safe execution environment. So there are guardrails in our implementation and eBPF that basically guarantee that what you're running there, right? Number one is isolated, is only there to run that specific function. All these eBPF programs are compiled just in time and run just in time every time they're invoked, right? And there's also checks and balances in place to make sure that the programs that you actually push to eBPF and that you run in the kernel are safe to run, don't have like loops or other problems like that in the code. So there is a code integrity check that happens. There is a safe and isolated execution environment, and there's also just in time JIT compilation and running of these programs. This can give administrators the security guarantees and the warm fuzzy, right, that what they're running in the kernel is actually safe. Now, it will be safe as long as you can guarantee the provenance of that code, right? I mean, if you don't know where the code is coming from, if you don't know, who wrote that eBPF program, I mean, that can be very dangerous. But yeah, but if you are working with Isovalent, you will run all these enhancements and capabilities in a safe and isolated manner.
And what do you guys use eBPF for actually?
So we have productized eBPF as a technology in two distinct offerings, both open source, by the way. The Isovalent team has donated these projects to the open source community. The first one, and most prominent one, is Cilium. It is the most decorated and starred networking project in the history of CNCF. Has become the de facto standard for container network interfaces in Kubernetes deployments, both in private and public cloud. And we enjoy, while the numbers may vary, we enjoy tremendous adoption. If you're interacting with Kubernetes clusters in one of the cloud scalers, chances are that that Kubernetes cluster is implementing the technology that Cisco acquired. On the other hand, in the private cloud use case, a lot of the OpenShift deployments that are being implemented, as well as other Kubernetes commercial distributions and sometimes open source Kubernetes, are running with Cilium or with Isovalent Enterprise, which is the enterprise distribution of the Cilium CNI. So that is one program, Cilium, and that is a networking project. Think connectivity, think observability, and think also security, network security, aka firewalling, right? For use cases like microsegmentation of east-west traffic inside of your containerized infrastructure. That is Cilium. We also started and donated another project called Tetragon, where eBPF is used in a different manner. In that case, the eBPF hooks and the eBPF technology is being leveraged to provide what is known as runtime security. This is the notion that you're not looking necessarily at the network traffic, although Tetragon has the ability to do some of that. There is definitely some overlap between Cilium and Tetragon when it comes to the disposition of the network traffic and enforcing security for network flows. So there's something there that could also and will also be implemented in Tetragon. But taking a step back, Tetragon is mostly focused on runtime security, which means I'm more interested in processes running inside of that container. Or if you deploy a Tetragon agent to a virtual machine, the process is running inside of that virtual machine. Can I create policies that basically, block a process from running, malicious or otherwise? So these are the kind of use cases, right? In this case, the observable and actionable thing in Tetragon is the compute endpoint, whereas the observable and actionable thing in Cilium is the network endpoint. So hopefully that creates an idea of how these two technologies are leveraged. And of course, the Isovalent Enterprise platform packages these solutions in an enterprise grade distribution, commercial distribution that we offer to customers who want to take advantage of all these technologies.
So is it correct to say that it's kind of taking networking and putting it in the kernel, because now you can actually see processes interacting with each other because they kind of do networking with each other? That means you can do the equivalent of access list, right, on a network, but between processes, and kind of block certain access and have a security aspect that was not necessarily available before between processes.
Yeah, that is actually a very good approximation, right, to the way Tetragon works. You can see those network sockets, and you can see that network traffic, and you can actually do some segmentation. You could actually do some security network segmentation using Tetragon. On the Cilium side, similar use case is handled by firewall policy, network policy, Kubernetes network policy. Filters of the traffic are actually implemented in eBPF in the kernel, but the traffic that is allowed or blocked is network traffic as opposed to like processes inside of a container and things like that. The main idea, which actually predates Cilium, this is something that in cloud computing has been happening for a long time, since the days of like, even we could even go back to Nexus 1000V and NSX and Open vSwitch. I mean, there have been like platforms over time that have recognized that distributing network services to the compute node and running those as close to the application as possible, something that, Martin Casado, one of the big luminaries, right, of the software-defined networking move, he used to call Goldilocks zone. Is there a place in the data center that is, not too far from the app as to lose context and understand it from that app, but not too close that if somebody compromises the app, then the security posture, for example, that app would also be compromised. And that place is essentially the compute layer. Call it your virtual infrastructure layer or your container infrastructure layer. Run it right there in the kernel of that compute node that is serving those applications, right? Where the applications cannot touch it, cannot touch this service. And the service is close enough to the app that it can actually infer and understand signals from the app. So it's a really good place to enforce security, observability, load balancing, and whatever you can distribute to the kernel. What Isovalent brings to the table, as we mentioned before, is the ability to do that with 21st century technology, right? Using eBPF.
And I have a question actually. You mentioned, I mean, all of that is open source. So what prevents competition from just, forking it and doing their own thing, benefiting from all eBPF advantages that we just talked about?
Absolutely. Yes. So yes, Cilium, Tetragon, eBPF, these are open source. Isovalent as a startup had its roots in that open source community. And also obviously the monetization strategy for Isovalent was to package the open source offerings in an enterprise offering that they could provide, where they could provide support, additional features that were not being released or shared in open source. So it's if you will, more of the traditional motion, right, of companies that leverage open source technology to then create a commercial offering. So from that perspective, that's a traditional motion. These projects are open source. And in fact, we're seeing that eBPF is now being used in so many use cases, specifically in networking and security, where um, our competitors could actually take this software and create their own solutions. We're also seeing that. And for us, that does not represent any kind of problem or issue. That is the spirit of these open source projects, right? And now the question is, you know, which company can actually take this technology and create products that deliver value to the enterprise, right? I believe that for the use cases that Isovalent is tackling, Isovalent is the best company. We remain to this day the top contributor to the Cilium project. We're very invested there. Our engineers routinely split time between writing features for our commercial software and also reviewing or writing features for open source. So our open source roots are untouched, and it's something that the Cisco acquisition will not change. We have been given guarantees that we're going to continue to invest in open source. And frankly, if we were to abandon that, if we were to walk away from that, that would create a huge problem, not only for the community, but also for ourselves. And not only from a credibility standpoint, but also from a product and technology, and having also a commanding voice in that community. So my answer, that's a long answer. The short answer is it's open source. If there are competitors that are going to be enabled by this technology, absolutely, they're welcome to use it. Let's do it. Bring it on. It's leveling the playing field. And, each company will have to take that and innovate in the way they see fit. And then, customers will decide which solutions make sense for them.
Being a Wi-Fi engineer, I can already see some applications like 5G. People talk a lot about putting applications at the radio access layer and as close as possible to the 5G antenna. So there's definitely a need for security there, and we're going to look at eBPF for that. And on the Wi-Fi layer, we're already allowed to load an IoT container on the access point to do some Zigbee electronic shelf labeling and stuff like that. But also there, you don't want to run any app, and you don't want it to kill your access point. So there's definitely a lot of avenues, right, to integrate into our products. But I think we have a couple of bigger products and on the roadmap, right? What are the biggest correlation we're going to do between Cisco and Isovalent?
So let me just make a comment on something that you said, because I think this is important, is how eVPF is spreading, and how eVPF is now being used for maybe use cases that we didn't even think of when eVPF was created, which is also a good sign, in my opinion, of the nature of this technology. If people are finding that they can take this eVPF hammer, and with this hammer, they can nail, a bunch of different kinds of nails. I mean, that's great in my opinion. But the comment that I wanted to make is our open source and community director, Bill Mulligan, has a report that he shares with the Isovalent team on the various eVPF projects that are started, or the eVPF based companies that are actually creating solutions. And it's an incessant amount of information that comes from Bill. He monitors, the eVPF adoption. And I want to say that almost every week we hear about a new capability or a new company or a new experiment that someone has started with eVPF. And I think that's wonderful. Now, what are we doing inside of Cisco with all these assets that we just acquired? Obviously, as I mentioned, Isovalent has been in the market for almost a decade. I could name, for example, a capability that was announced last year called Live Protect, where a Tetragon agent is actually running inside of an NXOS operating system to actually detect and block vulnerabilities, CVEs, that could be that particular version of an XOS could be vulnerable to or open to. So this is a great example of a technology where the target application to be protected was an application. And now we're extending the technology to protect infrastructure. That's very telling. And it tells you how we can always find novel ways of using this technology.
Is there anything else we're working on? That's the stuff we had heard about, Live Protect, because we're on the iOS and operating system side. But anything else you can tell us about?
Yes. Let me tell you a few things that are happening. You will know that we're also very prevalent in the Splunk space. I mean, there is a lot of integration with Splunk for like visualizing and understanding all these different signals, right, that are emanated from the platform. So there are dashboards and there are security tools, right, that are driven and managed from Splunk, and a multitude of use cases that are joint integration is starting. So definitely we are first class citizens in the Splunk integration ecosystem. And the opposite is true. We are on the isolated side also packaging our solutions with ready to use dashboards that our customers can use very quickly and start deriving value from. We also already talked about Live Protect, and some of the things that we're doing with Tetragon. I own two initiatives here in the business group. The first one is a solution that we're targeting, as we're going to launch, barring any unforeseen circumstances. We will launch with our 119 enterprise platform release, currently slated for late May. And this solution we're going to call Isovalent Networking for Virtualization. Isovalent Networking has been playing in the Kubernetes space for a long time, as we've mentioned multiple times. And we have a solution, a product called Isovalent Networking for Kubernetes. So we're extending our capabilities to now cover virtualization as a use case. And that's why my platform is called Isovalent Networking for Virtualization. What we want to convey with this product and the name and the use cases that we satisfy is that we're now going to provide the correct network and security abstractions to virtual machines running on Kubernetes, not necessarily containers. That's a problem that we already solved. Now we're solving the VM network and security use case, right? So now you can now migrate VMs to Kubernetes or create net new VMs in Kubernetes, and you can LAN wire those VMs to a network that is the right expression that that VM needs to actually operate in your environment. And the reason why this is important and why we cannot use what exists already in Kubernetes is that Kubernetes networking, at the end of the day, is networking, but it's very peculiar, right? Kubernetes networking actually behaves in the way that the typical application running on Kubernetes wants, right? Applications in Kubernetes traditionally have been ephemeral applications, stateless applications. This, of course, has changed over the years. I don't think we cannot say that that's a true statement anymore. But I'm talking about, how the origins, right, of the typical application that was optimized to run in Kubernetes. Well, these applications come and go. So IP addresses, for example, are fungible. An application that comes and go may grab an IP address one time, may then grab a different IP address the next time the application is instantiated. Imagine doing that for a VM. That would break the application. Over the years, we have made networking and security an unintended tier of our VM application environments. When you have a 3-tier app in web app DB and you want to migrate it, or you want to troubleshoot it, or you want to analyze it, it's not just web app DB that makes up that application. It's the network and security posture that makes web app and DB work. What is the connectivity? Is there a load balancer in front of the web tier? Do I have firewalls across these different tiers? Is there micro-segmentation already, right? So network and security are a tier of the app. So when you want to migrate an application, you also need to think about the migration of the networking and security posture. So we're correcting, we're enhancing Kubernetes networking to now express the correct network and security abstractions to the virtual machines that we want to run on Kubernetes. So this looks more like an enterprise network than a cloud network. So that's what we're doing. We call that feature Isovalent private networks. An Isovalent private network is a new network abstraction that we're creating in Kubernetes to, again, provide the correct network and security services to stateful applications such as VMs that operators want to run on top of a Kubernetes environment. The second thing that we're doing, which is also part of my product, is a new component that we're calling the Isovalent Network Bridge. The Isovalent Network Bridge is an appliance that you deploy to VMware if the VMs that you want to run on Kubernetes are actually coming from a VMware migration, and emphasis on and, you need to preserve the IP of that workload and the connectivity to that application environment before, during, and after migrations, because you want to do an incremental lift and shift of applications from VMware to, for example, Kubernetes. The bridge, that's the use case that the bridge solves. You deploy the bridge, and now the bridge is there spanning connectivity between these two clusters and providing the continuity in an IP preservation that application needs.
So it's virtualizing the network for the VM application, right? The application is agnostic of all that. It just sees like a regular network, and you're virtualizing it for that app, right?
Absolutely correct. The application that the VM that was running on a networking VMware, if it is migrated to a private network in OpenShift, or if you create a net new VM, because you can also hydrate those OpenShift or Kubernetes clusters with just net new workloads. If you create a new VM in that Kubernetes environment, you are connected to a private network. Yes, the VM will be none the wiser. The VM thinks that it's connected to a dedicated network that is getting an IP for all the things, right? It's network virtualization at its best. And we're doing that. And it's not an easy problem to solve, right? Because Kubernetes, again, was not designed. Kubernetes networking was not ideated, was not created with this use case in mind. So we're actually rebooting Kubernetes networking to accommodate this new form factor that is now coming to Kubernetes in full force called virtual machine.
My mind is blown a little bit because when I first heard about containers in Kubernetes, it was like, oh yeah, it's like a lighter VM, right? It's not a full VM, it's just a container. You can run a bunch of containers. It's much better, etc. And now we're actually loading VMs into Kubernetes networking. So it's like the loop is closed.
Look, I don't know who thought that VMs were going to go away. And VMs are not going anywhere. I could give you so many examples. I mean, number one, the vast majority of Kubernetes infrastructure out there in the world is running on VMs. So let's start there, right? We have agentic applications, right? For the most part, benefit from running on a VM or a meta VM, right? There are projects like Kata containers, Makevisor, Firecracker, right? I mean, these are examples of meta VMs that can run in Kubernetes because they provide an isolated code execution environment for the agent, which is deemed more secure and easier also to manage in some circumstances. So I think that between the fact that Kubernetes is now lingua franca for infrastructure, we seem to have found finally the infrastructure API that we're looking for that was very elusive. If I go to Cloud A, I have to do APIs of Cloud A. If I go to Cloud B, I have to do APIs of Cloud B. Is there a universal API that can normalize my consumption, irrespective of who's hosting that infrastructure, aka which cloud is hosting it? Well, Kubernetes seems to be it, right? The best answer to that. And now we're seeing all these different kind of like applications and form factors, right, are coming to Kubernetes. VMs because of agentic, VMs because of VMware migrations. I see it as inevitable. I think that Kubernetes is going to happen in this enterprise environment, whether our customers, and I say this again with the utmost respect, but whether our customers want it, know it, or like it, I don't think will matter much. I think that the business will impose an operational model that basically centers a lot of those operations around a Kubernetes infrastructure. And that will mean that application teams that have been managing Kubernetes clusters for a long time may be required now to run VMs for the business. Or VMware teams that were doing VMware for so many years, right, are going to be asked, right, to migrate to Kubernetes. So we're seeing these two motions, and Cisco is there to provide the right networking and security services for these applications, as well, of course, as observability and elasticity with load balancing.
I was going to say that rings an observability bell because the very first time I heard the word observability, I was coming from the Splunk syslog network, very basic level. And of course, yeah, you need to know what's going on in your network, right? But then doing some agentic AI, I discovered long chain, long graph, longsmith, where observability of your AI agents and workloads is really important to know, to troubleshoot it further. And now everything you've described is like observability at the kernel level, at the container level, networking level. So that's like 10 different degrees of observability where it really starts to make a meaning in my head. So that's really interesting.
Absolutely agree with that. I mean, observability, right, in its most fundamental form is there a way in my system that allows me to understand the system behavior by looking at it externally? Can I understand the internal behavior and the internal operation of that system by looking at it from the outside? That's essentially what observability means, right? And yes, you're right. I mean, this applications, Kubernetes networking, the fact that everything is so densely packed, there's a ton of east-west traffic, and which is going to explode even more with all this different agentic applications. There's going to be so much traffic processes that will need to be monitored to remain compliant, to remain secure. There's all these things. You need a platform that can scale and that can give you the right signals at the right time, right, in near real time or real time. So Timescape, which we haven't mentioned up until now, is the observability platform that we package with Isovalent. And there's also a very aggressive roadmap of extending Timescape observability or integrating Timescape observability with the portfolio of observability tools that Cisco has. And let me tell you something, observability sells. By the time I left Google, the observability business was just shy of hitting a $1 billion market cap for Google, right? So observability is also an area that where Cisco and Isovalent are investing a lot. We want over time, we want to see integrations between Isovalent and Nexus Dashboard, for example. We want to see more integration with Splunk. We want to see more integration with other products in the SVG and outside our business groups.
If I can simplify, like overly simplify this, I was scared 10 years ago, networking and IT in general was becoming so complicated. I'm like, how can we handle this? Because it's just way too much for, human beings to handle. And then we had like fabrics in the data center and enterprise. Like, oh yeah, this fabric system, it simplifies the access layer. You don't have to care about what's happening behind. So, okay, that's one level of simplification. And now all of this is also like simplifying observability, because if you don't know what's going on in your network, in your apps, I mean, it causes security concern, but also like a troubleshooting concern. Like something goes wrong, and then what? What you're gonna do? And you can't expect your IT team to be able to figure that out unless you have the right tools, right? Unless each payload is secure, each workflow can be troubleshooted. So this starts to make a lot of sense.
I agree with that, Nico. These are very complex disciplines, right? Networking, security, observability. There's no one single person or team, right, that can do them all. So we have products and solutions that are targeting specific persona in the operations NetSecOps team, for example, right? The idea is to give each one of those teams the instrumentation they need to do their job or detect the issues quickly. But yeah, Kubernetes is a very complex system, right? It's a stateful machine that does a lot, right? And the networking in turn that happens inside of Kubernetes has also become complicated and convoluted. Kubernetes doesn't work the way IP works. An IPv4 is an IPv4, just like it's always been, right? It's just that this notion of like ephemerality and distributed services, ingresses, way traffic enters and leaves the cluster. Do I need to NAT it, masquerade it? I mean, these things are fundamentally different, right, from how we've been doing data center networking. But rest assured, if you're listening to this and you're intimidated what the networking inside of Kubernetes, please know that the most difficult part, if you're a Cisco network engineer, the most difficult part you've already conquered, right? I mean, if you understand how IP works and how BGP works and how firewalls work, and you will understand Kubernetes networking. There's no doubt. You just need to like think of Kubernetes networking as being specifically designed to target a specific type of application that didn't require all this persistence, and that is what we're changing with private networks and all the things that we're doing for virtual machines. So yeah, very intimidating, but we are providing not only the tools and the instrumentation to help our customers, we also have trainings and labs, and we're very active in the community to help educate our field and also our customers on this technology.
Okay. I'm double excited because you've shown the roadmap for, I would say, the Isovalent main products. But there's also, like we hinted at, the fact that I think every Cisco business unit will develop some form of eBPF or integration, at their level. So I'm very excited to see what comes out in the various Cisco, businesses.
Yeah, and Nico and Tristan, another example, right? Another product that I want to mention here, and again, thank you for the opportunity. Another solution we just demonstrated this very successfully. We had a ton of traffic in our booth at Cisco Live Amsterdam a couple of weeks ago. Was our EVPN integration with Cisco Fabrics. We have enhanced the container network interface, the Isovalent platform inside of Kubernetes. We has been enhanced to now support EVPN layer 3 networking, or as it is known, route type 5. And the idea here is that now you can blend the networking of your Kubernetes cluster with the networking of your fabric. So if you're virtualizing your fabric with VXLAN, EVPN, and your fabric could be ACI or Nexus, we also have a roadmap to integrate with Catalyst. And also we're looking at the Sonic platform, maybe even Hyperfabric later. There's like a spectrum of integration plans that we have. But the one that we announced a couple of weeks ago was with ACI and Nexus. We didn't announce it. We showcased it. We were showing early versions of that. The plan is to GA this in late May with 119. And again, it allows you to now extend the networking that you create in the fabric. You can now extend to the Kubernetes node. So now your VMs or pods or containers, right, that are in Kubernetes can participate in the same networks of your bare metal nodes or whatever other applications you have on the other side of the fabric. It's a very, very powerful capability. And to top it off, we are also going to introduce support for a security use case. In those EVPN routes that we advertise and propagate to the fabric, in one of the BGP extended communities that we announced via multi-protocol BGP, we're decorating those BGP announcements with a security tag that then can be used by ACI or Nexus to enforce a contract in the fabric. So we're giving Cisco customers the ability to do fabric segmentation based on metadata that actually has Kubernetes relevance. In other words, you can now create a security posture in your fabric for your Kubernetes applications and not worry about the IPs of those applications because, as we mentioned multiple times, they change, they come and go. You just use metadata, a security group tag, or a PC tag if we're talking about ACI to actually enact and enforce those contracts in the data plane. Extremely powerful feature that advances the conversations of fabric segmentation, right? Which is also essentially one of the main use cases that products like Hypershield are also looking to address. So extremely excited about that. It was extremely well received. And it again shows the possibilities, right, of Isovalent and Cisco when we really put our minds together to actually create solutions that are going to mean something for our customers. So based on the feedback that we got in Amsterdam last week, this is going to be a hit.
Yeah. I'm relating that with my experience. So I'm supporting Enterprise Fabric, which is SDA Lisp, but then now there's the Meraki Fabric with EVPN VXLAN coming as well. And I know that's what's used also in the data center. And the two, I mean, it looks complicated when you hear about how a fabric works inside it. But the whole point is fabric is like, don't worry how it's connected. It's just connected. Everything's connected. You have a simple overlay and, don't worry about the details. And you have automation to take care of that complexity. So typically you don't really have to care about how it's connected. And now you're saying it's getting extended to the container eBPF level, so everything is going to be the network is just going to be everywhere. Doesn't matter if it's a real appliance, if it's a container, what, it doesn't matter where, how. That's just a detail, right? And you're just like connecting everything, and then you're going to use tag to identify payloads and write clear policies, because all that complexity you brought, like you cannot secure this with access lists. Access lists are from the 90s or early 2000s, right? You have to specify IP addresses, you have to specify port numbers. That doesn't make any sense if your network is actually very complex and if the payloads are moving left and right, hosted in different places. So you're just saying, yeah, this is this type of payload, this is this type of payload, who has access to what, and then a security manager can actually write those policies without really knowing how it's implemented, where it is, or that starts to make a lot of sense as a story as well.
Yeah. Yeah, absolutely. And imagine a situation now where we start spreading, whether it's CVPN or something else, because there are service provider use cases with maybe SRVs, right? It's going to be more interesting. But let's call it just again network and security blending of the container infrastructure and your physical fabric infrastructure. Imagine this integrating with Catalyst 9K for some of those campus use cases. Imagine this integrating with our SD Access, SD-WAN. You mentioned Meraki, right? And now there's also some interesting use cases that we're exploring with. We're integrating with ICE and PX Script. So now you can define policies using your identity in Identity Service Engine, and that policy and that identity actually carries meaning across your not only your SD Access, SD-WAN, campus infrastructure, but also your Kubernetes infrastructure. Right. So definitely a number of like very important use case and capabilities that again give Cisco customers additional benefits. And a lot of these things for ACI and Nexus will only require a software upgrade. You could be, as a customer, you could be enabling these advanced use cases on the same fabric that you already bought, right? So you keep extracting value from the switches and your investment, right? It's a gift that keeps on giving, right? I noticed a very positive reaction from the customers that I talked to last week. It's like, okay, yeah, I'm not on ACI, 6.2, but I can go there and maybe get this capabilities. Or yes, if I do this or that in Nexus, I could benefit from what you guys are developing here because I have a use case for it. So again, it is giving the Cisco investments, another chance of proving that it is the sound and right investment. And we're going to continue to look for opportunities to do more of that.
You got me convinced. Do you have a closing word, or I'm convinced already?
Well, first of all, Tristan, Nico, thank you again for hosting me. Hopefully, the listeners will realize that Isovalent has brought an interesting set of capabilities and products to a Cisco portfolio. And we're playing in a space where Cisco didn't really have a presence anymore. At the risk of repeating myself, but I'm going to say it one more time. Kubernetes networking is networking. Kubernetes networking is as real as physical networking. And we need to continue to win, and we need to continue to bring value to customers. We need to continue to accelerate adoption of Isovalent Enterprise and Cilium, because that is where we play, and that is where all the business opportunities for this particular platform and use cases exist. And so we cannot concede the Kubernetes layer. So if you're working on deals that include a Kubernetes use case, you need to be. We urge you to involve the Isovalent team in those conversations. We cannot abdicate the Kubernetes layer. It would be the exact same thing as saying, for example, oh, I don't care if the top of rack is not Cisco. Let's do it with Arista, right? At the end of the day, it's a top of rack. It's a top of rack. Unacceptable, right? So my ask, kindly, of course, but a little emphatic too, to the team is come engage us, right, in those Kubernetes conversations. We have the know-how in Cisco now to go have those conversations about cloud networking, cloud adoption, AWS, Azure, Google. I want to mesh. I want to do service mesh and all these use cases. There is a team now at Cisco that can have those conversations. And then we can also talk about how we can activate and leverage additional integrations with additional Cisco infrastructure. So that would be my call to action to the listeners, right? Don't give up the Kubernetes networking and security layer. It is as relevant to our future as winning in AI.
That's a nice closing word. Thank you very much, Marcos. It was great to have you.
Thank you, guys.
Thank you.
Pleasure. I hope to see you in person soon. And thank you to everyone listening to my diatribe here. I appreciate it.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us by searching for the channel called Cisco Tech Stories on your favorite podcasting app. We're also present on the Cisco Podcast Network channel, where you can discover other podcasts from Cisco. Feel free to leave us comments or questions on Spotify. Thanks, and see you next month.
On the hillside of the data center, little caballitos made of coal. Every part a tiny rancher, looking for a safer road. Packets running like the wild toros through the fences that we drew. I was patching rules at midnight, still they always leaked on through. Container corazon, how you talk across the wire, such a tangled song. Then came EBPF, quiet in the grain, little more buzz in the kernel, watching every vein. I finally understand. Isovalent drew the fresco of this cloudy land. Once I chased the ghost of latencia, hopes and traces on the sand. Every hop another pregunta, who will take me by the hand? Now the code sits close to high road, no mas guessing in the dark. Tiny judges in the kernel stamp each packet with a mark. Hey, container corazon, how you talk across the wire, such a tangled song. Then came EBPF, quiet in the grain, little more buzz in the kernel, watching every vein. I finally compadre, like a village in the sky. Cilium flowers on the border, draw a path and let them fly. If they stray toward the sombra, policia made of light turns them gently soft in fearment back to where the bits burn bright. Container corazon, now you dance across the wire in a simple song.